Jupiter drifts in the deep darkness of the cosmos, shining like a colossal lighthouse amidst a sea of stars. From afar, this planet appears as a massive orb adorned with vibrant streaks of orange, white, and brown, as if painted by the wild brushstrokes of the universe itself. Have you ever wondered what forces crafted those dazzling bands of color across the surface of this gas giant? Jupiter is more than just a planet. It's a living cosmic laboratory where mighty storms, ferocious winds, and enigmatic physics converge, challenging our wildest imaginations. Today's journey will plunge you into the heart of this giant, where everything is grander, fiercer, and more wondrous than anything on Earth. With a size so immense it dwarfs the combined volume of all other planets in our solar system, Jupiter is a world of staggering proportions. Its primary components are hydrogen and helium, the very elements that forge stars. Yet, unlike a star blazing with fiery glory, Jupiter harbors a mysterious inner heat, like a smoldering ember from the chaotic dawn of the universe. What ignites this deep-seated warmth? How do ferocious winds, racing at hundreds of miles per hour, carve the planet's spectacular cloud bands? Picture this: powerful jet streams roaring through the atmosphere, weaving a living marble tapestry where each streak tells a tale of chaos and order. Zooming in closer, Jupiter's face reveals itself as a masterpiece of nature. Radiant cloud bands, gleaming like pearls, intertwine with belts of rust and amber, running parallel to the planet's equator. These colorful stripes aren't mere static lines, they're the vivid signatures of relentless jet streams, moving at terrifying speeds that outpace any storm Earth has ever seen. In the brighter zones, ammonia ice clouds rise from the depths of the atmosphere, reflecting sunlight in shimmering shades of pale gold and white. In contrast, the darker belts unveil deeper layers of the atmosphere, where compounds like ammonium hydrosulfide paint hues of rust and amber that captivate the eye. Can you imagine it? A planet where cloud bands flow in opposite directions, like colossal atmospheric rivers, clashing and swirling in an eternal dance. These winds, with speeds exceeding 400 miles per hour, are fueled by Jupiter's internal heat, a remnant of its formation billions of years ago. The Coriolis effect, born from the planet's dizzying rotation, fractures the atmosphere into dozens of cyclonic and anticyclonic jet streams, creating alternating bright zones and dark belts. But don't be fooled into thinking it's all orderly. At the boundaries between these bands, chaos reigns. Tiny waves, swirling cloud tendrils, and white ammonia and water vapor clouds condense, rising like vibrant brushstrokes shaped by fierce wind shears. The result is a marbled pattern enveloping the entire planet, so breathtaking it could steal your breath. Our journey is enriched with stunning visuals from NASA's probes, paired with meticulous animations, bringing you closer to Jupiter's mysteries. What stirs in the depths of this planet? What strange phenomena lurk at its poles? And what secrets do its faint rings and distant moons, lost in the giant's blinding glow, hold? As we prepare to turn the page, brace yourself to explore a monumental storm, a symbol of untamed chaos and power, a phenomenon that has left humanity in awe for centuries. The Great Red Spot, a colossal storm raging on Jupiter, is a spectacle so vast it could swallow Earth whole. This swirling anticyclone, a high-pressure vortex spinning counterclockwise, towers above the surrounding cloudscape like a majestic titan of the atmosphere. Up close, its dense, oval-shaped clouds form a mesmerizing ring, painted in the faded hues of weathered brick. A high-altitude haze lends it a faintly reddish glow, though the exact chemistry behind this striking color remains a tantalizing mystery. Could it be complex organic molecules or phosphorus-laden compounds dredged up from the planet's depths? Within its core, spiraling bands and eddies twist like the eye of a cosmic giant, while ferocious winds, roaring at speeds up to 268 miles per hour, sculpt the clouds into a form that has captivated astronomers since its discovery over 150 years ago. Around the storm's edges, white ammonia clouds swirl in a frenzied dance, stretched and pulled by the relentless vortex. Every so often, smaller storms collide with the Great Red Spot. Some bounce off, while others are devoured by its immense power. This storm isn't just a feature, It's the undisputed ruler of Jupiter's atmosphere, its influence rippling far beyond its borders. Yet, in recent decades, astronomers have noticed something curious. The Great Red Spot is shrinking, its once mighty form subtly reshaping. At its peak, it was twice its current size. But don't be fooled, it remains the largest storm in our solar system, a churning behemoth that completes a full rotation roughly every 6 Earth days. At its heart lies a deceptively calm region, a quiet eye surrounded by the chaos of screaming jet streams. Above the storm, a dome of reddish haze floats, setting it apart from the brighter zones nearby. Deep within this giant, flashes of lightning occasionally ignite, illuminating the clouds from within like fleeting cosmic fireworks. Far below the cloud tops, the storm may plunge miles deep, though data from NASA's Juno spacecraft suggests it's relatively shallow compared to Jupiter's vast radius. Still, it looms far higher than the surrounding cloud layers, a towering monument to atmospheric fury. The Great Red Spot is, at its core, a massive high-pressure system with an astonishing lifespan, its winds spiraling upward in a way that's almost the inverse of Earth's hurricanes. Its longevity is so extraordinary that it may have merged with other ancient storms, evolving over centuries into the icon we see today. Beyond the Great Red Spot, Jupiter's atmosphere is a vibrant canvas of chaos, painted with countless smaller storms and vortices. Along the planet's belts, elongated white ovals, smaller anticyclones akin to the Great Red Spot, dot the landscape. Some endure for decades, while others flare up and vanish within weeks. At certain latitudes, a string of these ovals curves around the southern hemisphere, gleaming like a strand of pearls against the planet's turbulent backdrop. These white ovals can merge over time, as seen in 2000 when 3 smaller storms fused to form a larger one dubbed Oval BA, or Red Spot Jr. This younger storm later blushed red and grew to half the size of its mighty predecessor, a testament to Jupiter's ever-shifting drama. Between these storms, Jupiter's clouds teem with chaotic currents. At the boundaries of the planet's swift jet streams, winds weave intricate, filament-like patterns. Where dark belts meet bright zones, swirling eddies form, possibly Kelvin-Helmholtz waves born from air layers sliding past each other, crafting clouds that ripple like waves on a cosmic ocean. In some belt regions, small, dark barges drift through, while bright, popcorn-like clouds erupt, marking powerful convective thunderstorms surging upward. Unlike Earth, Jupiter has no solid surface to tame its winds, allowing storms to dive deep and endure far longer than any terrestrial tempest. Across the planet's curve, countless spinning structures, from compact vortices spanning mere hundreds of miles to sprawling chaotic regions where multiple eddies collide, paint a picture of relentless motion. As we linger on this turbulent world, what other secrets lie hidden in its swirling depths? What forces drive these ceaseless storms? And what new wonders await us as we turn to the next chapter of Jupiter's story? In the wake of the Great Red Spot, a turbulent region trails like a cosmic battlefield, where the storm's powerful currents disrupt nearby belts, spawning clusters of swirling vortices and pale clouds. This chaotic zone is a nursery for storms, a place where new whirlwinds are born amidst the churning shear of Jupiter's atmosphere. Can you picture it? A swirling maelstrom where clouds twist and tangle, giving rise to fresh tempests. Yet, amid this apparent chaos, a surprising order emerges. Each storm stays confined within its latitudinal band, held in place by the relentless grip of powerful regional jet streams. While Jupiter's equatorial and mid-latitude regions dazzle with their striped, chaotic beauty, an unexpected harmony unfolds at the planet's poles, revealing a spectacle unlike anything else in the solar system. As NASA's Juno spacecraft soared over Jupiter's poles, it unveiled a breathtaking sight: polar storms arranged in striking geometric symmetry. At the North Pole, 8 massive storms encircle a central point, forming a near-perfect octagon of whirling giants. Each storm, sprawling between 1,500 and 2,800 miles across, spins counterclockwise, their spiraling arms almost touching, yet they remain perfectly balanced, as if an invisible force holds them apart. It's a mesmerizing dance of nature, a synchronized polygon of cyclones that feels almost otherworldly in its precision. The South Pole offers a similar marvel. Initially, 5 cyclones surrounded a central vortex, later joined by a 6th to form a hexagonal pattern. These polar clusters have remained remarkably stable over years of observation, their shapes barely shifting. What hidden physics could orchestrate such delicate balance? Perhaps a perfect interplay of swirling currents and jet stream boundaries locks these storms into their places, like pieces of a cosmic puzzle. Suddenly, a brilliant flash pierces Jupiter's clouds, illuminating the planet's stormy depths. Lightning crackles across this alien world, its fleeting glow briefly setting the cloud tops ablaze with radiant light before darkness reclaims the scene. Jupiter's thunderstorms unleash bolts that rival, and often surpass, those on Earth. Since Voyager first spotted these fleeting sparks in 1979, we've known that lightning on Jupiter originates deep within water-rich cloud layers, where conditions mirror Earth's storms. But Juno's discoveries added a thrilling twist. Beyond the familiar deep lightning, Jupiter hosts shallow lightning, sparking high in the atmosphere within clouds of not just water but a strange brew of water and ammonia. In these frigid upper layers, where temperatures plummet to -126 degrees Fahrenheit, liquid water shouldn't exist. Yet Jupiter's abundant ammonia acts like antifreeze, keeping water liquid in extraordinary conditions. During intense storms, icy hailstones are hurled 15 miles above the usual cloud decks into ammonia-rich regions. There, ammonia melts the ice, forming slushy droplets of water ammonia, mushballs. Within these alien thunderclouds, collisions between rising ice crystals and falling mushballs generate static electricity, igniting lightning that crackles through Jupiter's upper atmosphere, far higher than we ever imagined possible. These shallow bolts flash through ammonia clouds, casting eerie blue and golden glows across towering storm structures. Juno captured these fleeting sparks on the planet's night side, each lasting mere milliseconds but shining nearly as brightly as Earth's familiar lightning. Deeper down, 30 to 40 miles below the cloud tops, more conventional thunderstorms rage, where water exists in all 3 phases, ice, liquid, and vapor, driving charge separation just like Earth's cumulonimbus clouds. Some of these bolts are colossal, releasing energy far beyond Earth's most powerful strikes. Juno's instruments even caught the eerie whistlers, radio signals from lightning humming through the atmosphere, a haunting soundtrack to this cosmic tempest. Thousands of these flashes were detected, painting a vivid picture of Jupiter's electric fury. Fascinatingly, Juno's discovery of shallow lightning solved a long-standing mystery: why ammonia seemed to vanish from Jupiter's atmosphere. Those mushballs, plunging deep into the planet, carry ammonia with them, redistributing it in ways we're only beginning to understand. As we marvel at these electrified storms and their intricate patterns, what other secrets does Jupiter hold? What forces shape its wild atmosphere, and what new revelations await as we venture deeper into this gas giant's mysteries? Once again, a brilliant flash of lightning slices through Jupiter's distant clouds, casting a fleeting glow over towering cloud structures that rise like monolithic castles above the surrounding haze. These convective towers, soaring up to 30 miles high, are driven by the planet's intense internal heat, a primal force that fuels its restless atmosphere. In that brief burst of light, we catch a glimpse of a colossal thunderhead, its jagged edges hinting at the origins of ammonia-rich hailstones that plummet through the storm's aftermath. Can you imagine the raw power of these alien tempests, sculpting clouds into shapes that defy earthly storms? Now, let's soar beyond the clouds and storms to a realm of pure cosmic wonder. High above Jupiter's poles, shimmering auroras dance with a brilliance that could outshine any spectacle in our solar system. Each pole is crowned with a ceaseless halo of radiant auroral light, bathing the planet's dark expanse in an otherworldly glow of violet and teal. Jupiter's auroras are the mightiest in our solar system, their energy dwarfing Earth's northern lights by hundreds of times. Unlike Earth's fleeting auroras, which flare only during solar storms, Jupiter's never fade. They pulse relentlessly, driven not just by the solar wind but by the planet's colossal magnetic field, a force estimated to be 16 to 54 times stronger than Earth's. Deep within Jupiter, swirling metallic hydrogen generates this magnetic might, capturing charged particles and funneling them toward the poles. When these high-energy particles collide with the upper atmosphere, they ignite hydrogen molecules, sparking dazzling displays of ultraviolet and infrared fluorescence. The result? Vast, oval-shaped auroral rings that encircle each pole, glowing with an ethereal beauty. In vivid images, the northern aurora shimmers with electric blue spirals, twisting under the grip of magnetic forces. These auroras draw power from Jupiter's rapid rotation, completing a day in under 10 hours, and from its volcanic moon, Io. Io's fiery eruptions spew tons of ionized sulfur and oxygen into space, which are ensnared by Jupiter's magnetic field. As the planet spins, it drags its magnetosphere along, hurling these ions toward the poles. Io's influence is so profound that it leaves a glowing footprint in the aurora, a distinct bright spot marking its magnetic connection to Jupiter's atmosphere. Similar footprints appear from moons Europa and Ganymede, each adding a sparkling accent to the northern auroral oval. Solar particle bursts can amplify these displays, making them flare even brighter in dramatic bursts of light. Observations from the Hubble Space Telescope reveal auroral curtains towering thousands of miles above the cloud tops, far grander than anything Earth could muster. Yet, here's a twist. Even if you stood within Jupiter's atmosphere, you wouldn't see these radiant rings in their full glory. They glow primarily in ultraviolet wavelengths, invisible to the human eye, and even emit high-energy X-rays, a phenomenon scientists are still unraveling to understand how these particles are accelerated. Now, let's pull back from the planet's surface and gaze into the void. Against the inky blackness of space, Jupiter is encircled by an unexpected marvel, a delicate system of rings, faint as gossamer threads. Unlike Saturn's bold, icy rings, Jupiter's are wispy, nearly transparent bands of dust, so subtle they went unnoticed until 1979. In images, the main ring appears as a slender, glowing arc hugging the planet's equator, flanked by a faint inner halo and a broader, diffuse outer ring. These rings shimmer faintly under sunlight, casting a pale white streak across Jupiter's night side, 1,000,000 times dimmer than the planet itself. Composed of tiny dust grains rather than glittering ice, they seem impossibly fragile for a gas giant's domain. So, what sustains these ethereal structures? The answer lies just beyond, in the orbits of Jupiter's smallest moons, whispering secrets of their cosmic dance. As we prepare to explore further, what mysteries might these moons and their delicate rings unveil in the next chapter of Jupiter's saga? In the faint glow of Jupiter's ring system, two tiny moons, Amalthea and Adrastea, glimmer like distant stars, their subtle presence barely discernible against the cosmic backdrop. In vivid images, Amalthea appears as a small white speck on the left edge of the ring system, its faint infrared signature captured by the James Webb Space Telescope, a whisper of light confirming its existence. Adrastea, even smaller, sparkles as a delicate near the main ring's boundary, a fleeting beacon in the planet's orbit. These fragile rings owe their existence to these moons, which tirelessly replenish them. Unlike Saturn's dazzling, icy rings, possibly the remnants of a shattered moon, Jupiter's rings are woven from fine dust kicked up by micrometeorite impacts. When space debris slams into the surfaces of moons like Adrastea or Métis, it launches tiny particles into orbit, where they drift and coalesce into a gossamer veil around the planet. Adrastea, a mere 12 miles wide, orbits at the very edge of the main ring, serving as its primary source of dusty material. Métis, slightly larger but unseen in this view, also contributes to the delicate structure. Farther out, the larger moon Amalthea, stretching 155 miles across, and Phoebe add their own faint trails of dust, forming wispy outer braids in the ring system. Data from NASA's Galileo spacecraft paints a clear picture. These rings are sculpted from the very substance of Jupiter's smallest moons. The main ring, remarkably thin at just a few miles thick, is a delicate tapestry of minuscule silicate rock fragments, their dark hues reflecting barely any sunlight. Can you imagine how ethereal they must look? Nearly invisible except in infrared or when backlit, they shimmer like ghostly threads weaving through the darkness. Jupiter itself is a dynamic masterpiece, a cosmic symphony where atmosphere, magnetosphere, rings, and moons intertwine in a complex dance of gravity and electromagnetism. Its iconic cloud bands stretch across its latitudes, cradling storms and channeling energy from the planet's fiery core. Deep within, Jupiter's internal heat, a primal furnace left over from its formation, drives relentless convection, birthing towering clouds and ferocious tempests. Invisible magnetic field lines stretch from the planet's depths, linking to the radiant auroras at its poles and threading through Io's volcanic eruptions, sparking electric currents that set the polar skies aglow. Jupiter's rapid rotation, completing a day in under 10 hours, orchestrates this grand performance, shaping the cloud bands, aligning cyclones, shifting the magnetic field, and flattening the rings into a delicate disk. From this perspective, Jupiter is a breathtaking interplay of motion and forces, fluid dynamics, electricity, magnetism, and gravity, all unfolding on a scale that dwarfs our imagination. It's a world where every element, from the swirling storms to the shimmering rings, harmonizes in a portrait of eternal change and immense power. Jupiter doesn't need a conclusion. It simply is a majestic gas giant, mysterious and endlessly dynamic, echoing the universe's creation and its ongoing drama. As we linger on this awe-inspiring world, what new stories might its moons and their intricate connections reveal? What secrets lie in the interplay of these cosmic forces as we turn to the next chapter of Jupiter's saga?